pop song before. I really like it. Hey everyone, I'm Lainey. This is Adam. As we were just introduced, we're software engineers on the GraphQL team at Facebook, and we are really excited to be here and to get to talk to all of you about GraphQL. What's our plan for today? I'm going to start with a brief intro to GraphQL, and then we're going to do a couple deep dives into some work that our team has been doing to keep making GraphQL better. So I'll do the intro. Adam will talk about how we're changing the way that we write GraphQL definitions. Then I'll come back and talk about the framework that we've developed for delivering real-time updates using GraphQL. And we'll wrap up with some pointers to more resources that you can use to learn about other exciting work going on. So as promised, let's start with the basics. What is GraphQL? Where did it come from? And why do we need it? The story of GraphQL starts back in 2011. The mobile revolution was underway, and Facebook was trying to figure out how to adjust. We were primarily a web company, so the natural decision that we made was to build our mobile apps using HTML5 in native views. Unfortunately, this didn't work out too well for our users and the resulting apps. The apps were pretty slow, unresponsive, and had a lot of crashes. So this is just one example of some negative press around our iOS app back in 2011. So we went back to the drawing board. By the following year, we had decided to rewrite our iOS and Android apps as native apps. This ended up being a much better experience for our users, but it required us to rethink our tech stack at Facebook, and in particular, to figure out what API we would use for these mobile apps to talk to our servers. One pretty natural option here was REST, but after some exploration and experimentation, we realized that REST didn't seem like it was going to meet our needs. So in particular, if we designed our REST API so that each endpoint delivered a single entity, we wound up making a lot of different round trips to the server and had apps that were slow to load. If we tried to fix that by creating custom REST endpoints so that we could deliver exactly the data we needed for each particular view, then we had this kind of explosion of different endpoints on the server. And that problem gets even worse when you think about the fact that we wanted to release different app versions at a pretty quick cadence, so we were going to need to be supporting a bunch of app versions at the same time. We thought that with REST, we might be more likely to run into bugs related to overfetching, underfetching, and maybe that we would have to move more slowly because of all this maintenance of different endpoints. So what did we do instead? We developed GraphQL to power our mobile data fetching. Today, GraphQL supports nearly all of the mobile data fetching at Facebook, which means that it serves hundreds of billions of queries per day for thousands of different versions of our various mobile apps. The best way for me to describe GraphQL, explain how it works, is to give some examples. So here's a really simple GraphQL query. I'm asking for my name. Here, me and name are called fields. And I can take this query, send it as a string to a GraphQL server, which will parse it, execute it, and then return this response. So the first thing you should notice about the response is that it looks pretty similar to the query. Each field in the query has a corresponding JSON key in this response, and that's not an accident. This is true in general of GraphQL. The shape of the query describes the shape of the response that you expect to get back. Here's a slightly more advanced query. Here I'm using the user field, and I'm asking for the name of the user with this ID. So in this case, ID is called a field argument. You can basically think of GraphQL fields as functions, and just like functions sometimes take arguments, same with GraphQL fields. And this would be the response. Fields can also return objects, and then you can use nested fields to query for more information on those objects. So in this case, profile picture returns an object, and I'm asking for the width, height, and the URL of that object. And so one thing to note is that if I had just put me, name, profile picture, that actually wouldn't be a valid GraphQL query. You need to specify all the way down to scalar leaf nodes so that there's no ambiguity about what exact data you are asking for. And then one really neat thing about GraphQL is that you can query lists of things, which we call connections. So with just one query, I can ask for my name and the names of my friends and get a response back that might look like this. Hopefully, I have more than 3 friends. And you can even go deeper and do things like my name, the name of my hometown, and then that same information for all of my friends. So as I mentioned, GraphQL powers virtually all mobile data fetching at Facebook, but it actually is not just for Facebook anymore. Back in 2015, after 3 years of using GraphQL internally and improving it, we decided to open source GraphQL. So you may wonder what it actually means to open source this thing, since it's not just some code. It's actually a language and a protocol for clients and servers to communicate. We ended up open sourcing 2 things. So one was a spec, which describes GraphQL, and the second was a reference implementation in JavaScript. Since we open sourced GraphQL, we've seen a ton of really awesome work in the community. So there are implementations of GraphQL servers in over a dozen different languages. There are great GraphQL clients like Relay and Apollo, and a lot of other companies have started either using GraphQL or at least experimenting with it. So even talking to some of the other speakers yesterday, I learned that a couple of them have been using GraphQL, which is really exciting to see. We could spend the rest of our talk just discussing the GraphQL ecosystem, but instead I'm going to point you to graphql.org as a place to learn more about everything that's going on. So that was a pretty tidy story, right? We had this problem, we wanted to transition to mobile, we designed GraphQL, and it solved all of our problems. So, right? Actually, not quite. Today we've had GraphQL at Facebook for 5 years, we've had it open source for 2 years, but there are still a lot of things that we're continually trying to do to make the process of using GraphQL better for our users. And today we're going to jump into 2 examples of that. I'm going to hand it over to Adam first to talk about the way we've improved the process of writing GraphQL definitions.
Thanks. So you're probably asking a question like, okay, me, name, hometown, profile picture, where do all of those words come from? How does GraphQL know what those are, what a me is, what a name is? Those things are defined in the schema. So a schema looks something like this. You just say that you've got a type. That type is the user type. And then you declare that the user has fields. In this case, the user has a few fields called name, hometown, friends, and profile picture. And those fields have types. So I work on the GraphQL server team, so I'm effectively writing a server to take queries like the ones that Laney showed to know what a user is, what a name is for a user, that sort of thing, and to effectively do the processing on the server side to answer the queries that people produce. Schemas are effectively the type system for GraphQL, but even though GraphQL is strongly typed, your language may or may not be. So when I say your language, our language at Facebook is Hack. We have a web server. We're not just a mobile company, in case you were wondering. And the backend that serves all of the GraphQL queries produces all of the information for our mobile and JavaScript clients is called Hack. So what we do by talking about GraphQL schemas and writing a server that has a certain schema definition is effectively bridging 2 separate type systems to be sure that one type matches to another type so that you get runtime and compile time guarantees that you're not accidentally going to send the wrong data out in response to a query. So that's basically what I'm going to talk about here. Your server's implementation matters a lot because the way that you write your schema on the server is going to effectively allow you to make certain assumptions when it's time to actually answer queries. So talking about data layers versus implementation layers is something we always sort of do at GraphQL. When you write a GraphQL schema, it's effectively data layer agnostic. You can have any sort of data layer underneath GraphQL's server. Your server can do anything to fetch the data. The client engineers who are writing the queries to query, in this case, the social graph, but it could be any graph, to query the social graph are just asking questions about objects. But the server is actually processing those questions and answering them. The client engineers are operating above the data layer, which is one of the beauties of GraphQL because they don't need to know the server implementation. If you're working on a JavaScript client, you might not want to know the next generation awesome version of PHP. PHP scares a lot of people. You've got your JavaScript thing down. But it turns out that those server engineers are actually pretty darn good at writing their own APIs for exposing the data to make the website itself work. So at Facebook, we have web servers. We have a lot of great code, a lot of great APIs in the web servers to serve the web. Why can't we just tie those directly into GraphQL and to say that the GraphQL schema is actually just our Hack code base? What I'm suggesting you do is that you tie your type systems together, the GraphQL type system, and in our case, the hack type system, as cleanly as you can and as tightly as you can. Next, I'm going to tell you not to edit your own schema. Now, if you go on graphql.org, it's going to say, go ahead and just write your own schema. Just type out what types you have, what fields they have, what types those fields have. I'm going to say not to do that if you're actually trying to operate something at scale, if you're trying to write code that is correct every step of the way. What I'm going to suggest instead is that you follow our approach, which is to effectively annotate the types that you have or the classes that you have in whatever your programming language is to just indicate how they correspond to GraphQL types and fields. So in this case, this is, do I have a laser pointer? It's too big of a risk. I'm not going to push anything. So in this case, on the left-hand side, you have what we call an introspection query. GraphQL is really neat in that you can use GraphQL to ask GraphQL questions about your GraphQL server. So this is I'm asking GraphQL for the type named user. For the type named user, I'm asking for that type's name. We know it's user. And its description. And then we're asking for fields on the type and the name and description of the fields on the type. On the right-hand side, we've got some hack code. It looks like PHP code. Hopefully, it doesn't make or hopefully it's easy enough to understand. But up at the top, we're just annotating the user class, which is, in theory, powers the notion of what a user is for Facebook. So it's like kind of important. And we're annotating it to be exposed as the GraphQL type user with a description of a Facebook user. Similarly, every method in the class has the option of being exposed as a GraphQL field. This field lives on the type, and therefore, we're able to actually say that the types and fields exposed through GraphQL are the actual APIs that our server engineers produce and provide for building the website itself. So this allows us to tie our mobile development and our PHP development really tightly together. Then, and this is the crazy part, we use code generation to save us from all of the mistakes we would make if we were writing a schema ourselves. So earlier, I showed you something that looks like this, which is to say we've written a user class that's being edited by people all the time. How do we make sure it still corresponds to and provides the right number of assumptions that are made by the GraphQL server? The answer is that we generate code. We write code to read our own code and then look at the annotations for that code to write additional code, which is the code we execute with the GraphQL server. That makes sense, right? This is the best thing. It means that we're able to tie our tightly tied together type systems into our runtime artifacts. So the GraphQL server is actually running on code that's generated from the annotations of the code that backs our actual user types. This allows us to map between our type systems at build time. So when we say we're going to build our GraphQL server, our GraphQL schema, we're actually looking at the user type. We're ensuring that it's fulfilling all of the assumptions of the schema as annotated on the user type. And that means that our runtime is effectively type safe without ever having to look at it, without ever having to use those assumptions, which makes things a lot faster and a lot safer. And we're effectively disconnecting those things that could be broken due to user error. And by user, I of course mean hack engineers like me. So it effectively ends up looking like this. We take an annotated class called user. I'm just reformatting it, but this is basically the same code. And then based on those annotations, we create a new class called GraphQL user type or something akin that has all of this stuff just hard-coded in. Another great thing is that those annotations don't need to be read or processed at runtime in hack. That would be real slow. Instead, we just have string literals that are super easy to compile, which makes things much faster. And then, of course, we get the same correspondence between the fields and the types. So our schema ends up looking like the thing on the bottom automatically because the types that we define in our PHP system have a one-to-one correspondence, or maybe a slightly less than one-to-one correspondence, but you can add more annotations to clarify that, which means that we are able to consistently ensure that the things that we're generating meet the assumptions of the schema. This means that at compile time, build time, and run time, everything is effectively tied together. Your native code ends up sound. At build time, we make sure that the mapping is correct, and then your generated code ends up sound. And then your schema and queries are sound, so you can just go ahead and execute whatever's going on and assume that passing everything literally through to the PHP web code is safe. That means your type systems match at runtime, and you don't need to actually use that assumption at any time. Same thing goes for queries. When you run a query at design time, you just need to make sure the query runs. Then at build time, we make sure that the query undergoes validation with respect to the schema. Then we know the query works. We know the query works with the schema, thanks to generating all this code. And then the validated parsed query text can just be cached, given an ID, and then at runtime, we just grab the ID, throw all the safety checks out the window. We know that they're already there, and everything is faster, cleaner, better, all those things that, engineers like. So in sum, tight coupling keeps your schema and server synced. The way I like to think of it is that it's kind of like one of those nightclubs or bars on the top of a skyscraper in Thailand. It's like you've got this whole thing just launching up. It's your entire web server. Then there's like this awesome layer, which is the GraphQL server, and then there's the sky. And in order to do that, you have to sort of work on every step, work on all of those connections very carefully so that the next step doesn't need to make those assumptions. So now I'm going to give it back to Lainey, who's going to talk about real-time updates.
Great, thanks. So we on the GraphQL team work really closely with product teams across Facebook. And a couple of years ago, one thing we started to notice is that for the products that people wanted to build, it wasn't enough anymore just to have a fast initial load. Users started to expect an experience where if something interesting happened while they were kind of just browsing through the app, they would know about it immediately. So this could be something like a new notification, a new comment, a new message, or even more obscure things like the sports game score changing or the price changing on a for sale item or someone reacting to a live video. So we started to notice that this type of real-time experience was needed. A lot of people were implementing real-time using polling. Polling is easy to understand, it's pretty easy to implement, and it can work really well, but sometimes it can have issues at scale, and we started to run into these. So in particular, you might have an issue where if you have a short polling interval, you're asking the server for more data, and there is none, and you're asking again, and there is none, asking again. You're wasting CPU, and you're basically just making everyone angry. On the other hand, if you have a long polling interval, what can happen is you might have latency issues. Something will happen, and maybe you only poll every 30 seconds, so you wait, and then you finally get the update. So things don't feel as snappy as we want them to. So over the years, some people at Facebook had come up with one-off solutions to try to address these shortcomings of polling. When I started working in this real-time space about 2.5 years ago, the main solution here that someone had built was built on top of our web chat infrastructure in 2010, and it was built to deliver live comments and likes in newsfeed. So you all probably know that 5 years, 2010 to 2015, is a really long time in the software world. This was a cool new system when it was first introduced, but by 2015, it wasn't in great shape. So it was web only, it had a lot of bugs, it was pretty old, and we looked into extending this system to try to work from mobile as well, and we realized that it really wasn't that flexible the way it was designed. So for a given type of update, like let's say live comments, the set of data that we would send out to different clients was exactly the same no matter what. And so we started to run into this question of what happens if our website and our mobile website and our iOS app and our Android app need different data to render a comment? Or even if different versions of the same app over time need different data to render a comment. Well, we could try stuffing all of the data that any client might ever need into those updates we were sending out, but then that's pretty wasteful. Or we could get into this game of trying to do custom logic for each version of each client. But these problems hopefully sound familiar. They're essentially the same set of problems that we saw with REST when we were first getting into the question of how to do mobile data fetching. What we really wanted and needed was a way for clients to be able to say, this is what kind of updates I want, and this is exactly the data that I need for these updates. And that, as you might have guessed, is where GraphQL comes in. So I showed you before how we can use GraphQL queries to do data reads. There's also something called GraphQL mutations to do data writes that we haven't mentioned so far. And GraphQL queries and mutations are both part of the open source spec, and they had been used for a while. And it was at this time, a couple years ago, that we realized there was a need for a third step here, what we call GraphQL subscriptions to do data updates. So just like I showed you through examples how GraphQL queries work, I'm going to do that with subscriptions. This is what the GraphQL query might look like to subscribe to new comments on a post. So I want to know what new comments are coming in on the post with this ID, and for each comment, the things I care about are the name of the author and the text of the comment body. And so it's a little different than a query where I just send the query and I get a response. With GraphQL subscriptions, I subscribe, and then during the time that I'm subscribed, before I unsubscribe, I'm going to get a stream of responses. So I might get nothing if no one comments, or I might get one or many updates for the subscription. So maybe I would get one that looks like this, and then later on I might get one that looks like this. And so our implementation of GraphQL subscriptions at Facebook is backed by a pub subsystem. I go into a bunch of detail. Last year I spoke at React Europe and I kind of described this whole workflow. So if you're interested in the details, I would recommend checking that talk out. For now, I'm just going to point out two parts of this that I want you to remember for later. So the first is that GraphQL subscriptions, as we've built it, uses topics, what we call topics. So this is how we match up publishes coming in, like new comments being written, with subscribers. So these are just strings. They might be something like comment create and then an ID. So that's the first thing to remember. And then the second thing is that when we do have a match, when a publish comes in and there are folks subscribed to that topic, what we do is the pub sub layer will call into our GraphQL server to run that query and then generate those updates that we want to send through to the subscribed clients. Today, GraphQL subscription supports a lot of different use cases at Facebook, ranging from the classic examples like live comments to parts of newer products like live videos, Facebook stories, marketplace, and also people have been using it to build internal tools for our own developers. We have over 100 subscriptions in our GraphQL schema at Facebook, which is roughly the number of, so live comments is just one of those. This is roughly the number of different use cases we're supporting. And we deal with hundreds of billions of subscribes coming from different clients, web, mobile, relay, et cetera, each day. One of the most exciting parts of 2017, at least for me, has been that we open sourced subscriptions earlier this year. So this was people from my team at Facebook, but also folks from Apollo and other people in the GraphQL community working together to go through this RFC process and add both a spec and code into open source GraphQL. So I encourage everyone to check that out. I'm going to spend the last couple minutes talking about some lessons that I've learned from working on GraphQL subscriptions that I think are pretty interesting. The first thing is that having an easy, clear way to configure subscriptions has turned out to be really important for the success of this framework. When we first started working on subscriptions, we weren't really focused on this question of configuration and settings because we were pretty much just trying to get everything to work. So what we did was we exposed settings that were the easiest things to implement in the underlying pub sub layer. What this ended up meaning is that the main settings that we were exposing to our users were at the topic level. So what does this mean? Let's say that Adam wrote a post on Facebook and we're all looking at it on our phones. There was this setting, total updates per second, that we were asking people to configure, and this would limit the total number of comment updates that we could deliver to everyone looking at Adam's post, let's say, per second. So the other weird thing was that this was kind of implemented in a probabilistic way. So there were basically coin flips and some round robin stuff happening. And when you think about if you're the one building live comments, this is pretty bad. What you really want to be thinking about is one person looking at their phone, looking at Adam's post and their experience. But we were forcing people to translate to this weird system that didn't make a lot of sense. And so we eventually realized about a year ago now that the way we were doing configuration was limiting the adoption of GraphQL subscriptions because it didn't give product developers what they needed to build the experiences they wanted. And so we ended up doing a pretty major re-architecture of our pub sub layer so that we could expose per subscriber settings. So things like when I'm looking at a post, what is the maximum number of comments that I'm going to get per second? And we also eventually were able to expose more sophisticated things after this re-architecture, like preferentially delivering updates from friends or using ranking as a factor to decide which updates to deliver for things like live video comments, where there's so many comments coming in, you just need to pick a select few to actually deliver through. And with this configuration question, we definitely deal with this trade-off, which I'm sure most or all of you have dealt with, which is people come, they're working on a product, they have some requests for how they want to configure their subscriptions, and we have to decide, basically, we want to be able to enable them to do what they need, but we also don't want to end up with something so complex that no one understands it. So today we have a web UI that people use to configure subscriptions, and it does a nice job of progressively disclosing complexity, but this is always a fine balance that we're trying to walk. A second lesson is that the traffic from GraphQL subscriptions can be really different than the traffic that you'll get from request response or even from polling. So in particular, it can be pretty spiky. Let's say that there's a big live video going on and someone writes a comment on it, and we're trying to deliver that to a lot of different people who are viewing the video. And this can cause problems with backend systems and backend databases if you aren't careful. One thing that we've done at Facebook to deal with this is we've batched requests together. So when I pointed out that step where the pub sub layer sees a match, sees a publish just came in and 1,000 people are subscribed to this topic, let's run the GraphQL queries. We actually do run those queries in batches. So we'll do one request and let's say generate 100 people's updates. This lets us reduce the number of database requests we're making, but there are some caveats here. It can increase latency, and it definitely increases complexity. So this is, I'm more mentioning this as an experimental thing we're trying out to deal with this problem of spiky traffic. It's more, take it with a grain of salt, but it's an interesting thing to think about. And then the third and final lesson is that debugging real-time systems is really hard and an exciting challenge. If you imagine you're trying to build, let's say, a Nordic.js RSVP app, and you've built it all, it's ready, and you have Adam test it out, he RSVPs, and his face doesn't pop up. You start to think about what could have gone wrong where. There's a lot of things. Maybe there's a bug in the app, and you didn't subscribe successfully. Maybe the publish never happened. Maybe it happened, but it went to a different topic. Maybe everything worked all the way through until the very end, and there was something wrong in the app's rendering logic that didn't cause it to update. So I think there are 2 steps to doing this well, and we're at maybe 1.5, step 1.5. So step 1 is just logging the data at all of these different steps, which it sounds really easy when I say it, but it actually took us quite a while to get the events logged from the pub sub layer, from the GraphQL executor, and all of the different clients that use GraphQL subscriptions all in a consistent way to one single place. And then step 2 is displaying the information in a way that's really intuitive and useful. And this is where I would say we're halfway there. We have the data. Unfortunately, it's in you have to check a few too many places to really understand the story of what might have gone wrong with your GraphQL subscription. So our team is currently working towards something that we like to compare to the Domino's pizza tracker, which shows you when you order a pizza exactly what step your pizza is in. So this is essentially what we're trying to build, just one place where someone can come and say, hey, I'm trying to build this GraphQL subscription for product X, and it didn't work, and understand what might have happened. And then the meta lesson is that there's a lot left to do in this real-time space. I think this journey 1% finished is a pretty good quote for it, just that we've built something, it works for a lot of people, but we're constantly seeing requests that our system doesn't satisfy, and I think that now that it's open source, it's really exciting because it means that we can learn from what everyone else is trying and learning in this space. So I'd love to talk to people about it later today or tomorrow if anyone has good stories about real time. Now I'm going to hand it over to Adam to wrap it up.
So if Sasha's right and 2018 is the year of GraphQL, what is GraphQL going to be bringing to 2018? We have a few things that we're working on that I'm just going to touch on really quickly because I'm not going to go over time. Check out Yuji Zhang talking about Relay Modern, a JavaScript client that we're working on for GraphQL. You can find her talk online. It was from F8 last year. If you're interested in this notion of streaming, everyone talks about streaming, so of course we had to mention it in our talk. Streaming or deferred queries, batching, or even live queries. You can look at Laney's talk with Lee Byron at React Europe last year. You can also check out our discussion of client SDKs. So I talked about code-genning everything so that your server is safe. Why don't we just use the schema to code-gen native objects for all of our clients so that they can use GraphQL without even knowing that they are? Dan Schaefer talks about that at GraphQL Europe last year. And if you want other stuff, graphql.org/community has talk after talk after talk about GraphQL. Hopefully that's what's going to lead you to an enjoyable experience of it. Thanks.